Hi, I'm Forrest. I'm a graduate student at the University of California, Davis. A lot of my research that I perform is actually at the Stanford Synchrotron Radiation Lightsource. One of the hutches behind me, being 4-3, is one of the hutches that we use at this light source, or the synchrotron, to perform some of our research to explore both the structural and electronic properties of materials that we use as catalysts for carbon dioxide reduction in our lab. The one word that I would use to describe my research is all-encompassing. I've had the fortune of working with a broad variety of applications ranging from batteries to metal intercalation to catalysis, all the way to looking at storage of radioactive material meaning uranium, in rust, and exploring how these different chemical properties of these are changing as you're performing different tasks on them, such as applying electrochemical bias, or even different synthetic parameters, and seeing how these changes are directly affected in our beamline by exploring both the structural and electronic properties of a wide range of materials, ranging from rust with iron oxides to metal chalcogens such as MOS2, and materials known as Chevreul phases. A lot of the journey that I've been a part of has actually involved a large range of scientists, and that's the greatest part about science, is that it's kind of that universal language, is that you get to interact with people around the globe, working together for a common goal to push science beyond the boundaries that we've ever been at before. One of the first days that I've worked at the synchrotron was extremely overwhelming in that I showed up, I had no idea what was going on, and a beamline scientist, Ryan Davis, actually walked me through the process step by step, all the challenges that we'd encounter, and actually helped in the data acquisition and processing post-fact. A lot of the things that I would actually recommend to newer users at light sources is to reach out and pick the brains of your beamline scientists and the staff scientists around you. They have years of knowledge beyond you, and while it could seem very overwhelming to show up by yourself or with the team and not have a lot of the knowledge of, what am I doing here? Look how complex this is. They could actually walk you through the steps and allow you to become an individual user operating on your own, being able to kind of tinker around with it to optimize the setup for your sample specifically. One of the ways that I've gone and survived my times at the beamlines, especially when you're working 80, 90 hours a week, where maybe you're working night shifts. Specifically, I'm a night owl myself, so I've always volunteered myself to be a part of these, is when I come with the team, we'll run these samples for 1 hour a sample, but we'll generally bring about 50 to 60 different materials that we want to try and explore. And what we'll end up doing is we'll have 50, 60 hours that week that we'll dedicate to running these samples, and that really does require a team effort to kind of get through it. One of the greatest motivators for me in terms of performing the science that I do is that a lot of the different effects that we actually observe in terms of climate change there's a large disparity between developed countries and non-developed countries. When I went and explored a lot of the countries that I did in Europe and South America, you actually get to observe kind of some of the energy demands that they need, as well as some of the climate effects that they're actually experiencing right now. And seeing those in first person and up front really does change your perspective on how we can try and fix this problem as soon as possible, as well as helping as many people as we can around the globe. This problem that we're experiencing in terms of energy demand and climate change, and this duality between the two, is an ever-increasing issue that needs to be solved now more than ever.